Okay, so let's see the structure of Zn. So we have the following theorem. So theorem 2.9. So so when we look at Zn, sometimes we have that there are equations that have solutions that where elements are invertible. So what do I mean by the equation having solutions? There is a particular equation that is of interest where that equation has a solution, all right? So this equation is of the form ax is equal to 1. So this equation is of interest because when we solve the equation, we get in the real numbers the inverse elements, all right? So then this is of interest because we can have elements can be invertible and allows us to extend equations to other conditions as well and solve algebraic equations. So let's do that. Let's prove that result. So let A and N be integers. With N greater than 1, then the equation ax x is equal to 1 has a solution in Zn if and only if the GCD between A and N is equal to 1 in Z. So let's prove this result. So first, assume that the equation has a solution. First, assume that the equation has a solution. And we will show that the GCD between A and N is equal to 1. So first, if W is a solution of A times X is equal to 1, then we have the following. We have A times the class of W is equal to the class of 1, which means that A times W is congruent to 1 mod N in Z. So what this tells you is that A times W minus 1 is equal to K times N. Therefore, A times W plus N times minus K is equal to 1. So we denote A and N by D, and since D is a common divisor of a and n. There are integers R and S such that d times R is equal to A and d times S is equal to N. So therefore it follows that we have A times W is plus N times minus N times minus K is equal to 1. So then you have D times R times W, because A can be written as D times R, plus and N can be written as D times S minus K is equal to 1. So therefore D divides 1. Is equal to 1. So therefore D divides 1, and that means that the GCD between A and N is equal to 1. Okay, as the GCD has to be bigger or equal to 1. So now we'll assume, so the reverse implication is that assume that D and N is equal to 1, and we show that the class of A times X is equal to the class of 1. This has a solution in Zn. So we've already done this before, but so since the class of D and N is equal to 1, so that means by Bezout's theorem we can rewrite things, and so what we get is that we get this equation here and we would be done. So I wanted to explain it quickly, and here it is. So let me just, before we close this subsection off, let's discuss units and zero divisors quickly. So, so something is a unit, an element is a unit if the equation AX is equal to 1 has a solution. So an element in Zn is called a unit if the equation AX is equal to 1 has a solution. Okay, so that means that there is an element B such that A times B is equal to 1. So in this case we say that B is the inverse of A. So an element. So in other words, A if there is an element B in Zn such that A times B is equal to 1. In this case, we say in this case, we say that B is the inverse of A. Okay, so stated like that, we can rewrite the theorem before in terms of units as well. So sometimes collapsing languages is very important for IQ, so it's important to know that. So let A and N be integers with N greater than 1, then the class of A is a unit in Zn if and only if the GCD between A and N is equal to 1 in Z. Yeah. So all of this at core really depends on the Bezout's theorem, which at core really depends on how well things set with respect to each other. So there is structural integrity involved here. Okay, so a non-zero element A of Zn is called a zero divisor if the equation Ax is equal to 0 has a non-zero solution. So that being said, I will close off this subsection and we'll solve some problems in this subsection and we'll take it from there. So thank you guys, and I'll see you guys later. Bye now.